we want to find the limit as x and y approaches 0, 0 of x cubed times y over x to the 6th plus y squared. This one is going to be 0 over 0 when you plug in x and y is 0. So we're going to find different paths to get different answers. So notice that the highest degree in the denominator is x to the 6th. So the trick here is, can I make a substitution for y so that all of these guys, when multiplied or substituted, will have an exponent of 6? Well, what times x cubed gives me x to the 6th? Well, that's going to be x cubed. What squared gives me x to the 6th? That's x cubed. So we're going to let y equal a constant times x cubed. And the reason we're going to do a constant is because we want to show that the limit will depend on whatever that constant is. Okay. And also, why did we choose x cubed? And why do we care about getting everything to the x to the 6th power? Well, the reason we do that is because we want to then divide by x to the 6th. Those are going to cancel. So then you get a number or a fraction that does not depend on x or y. So let's substitute kx cubed for y. We have kx to the 6th all over x to the 6th plus k squared times x to the 6th. I can eliminate x to the 6th now to get k over 1 plus k squared. So this limit is just going to be k over 1 plus k squared. And notice that the limit depends on the value of k. For example, if k is 0, the limit is 0. If k is 1, the limit is 1/2. So because we get different limits for different paths, we'll say that the limit does not exist.